So in this video, we're going to talk about rational exponents and radical expressions. First, what are rational exponents? Rational exponents are exponents that are in fraction form that represent a combination of power and root. The easiest ones to understand are those rational exponents where the numerator is 1, because those just represent a root. So for example, 9 to the half power is the same as square root of 9, which is 3. So if 9 to the half power represents the square root of 9, what does 8 to the 1/3 power represent? Well, it represents the cubed root of 8, which means what number raised to the third power equals 8, or what number multiplied by itself 3 times equals 8? The answer to that is 2. So then what does 625 to the 1/4 power equal? What does that mean? That means we're looking for the fourth root of 625. So what number raised to the fourth power equals 625? And that is 5. But not all rational exponents have a numerator of 1. Some rational exponents have a numerator other than 1. So how do we understand those and what do we do with those? So let's take, for example, if I have here 25 to the 3/2 power. So when you see a rational exponent like this, what you have to realize is that the top number represents the power and the bottom number represents the root. So in other words, what 25 to the 3/2 power represents, okay, or means, is that I'm looking for the, if I take a look at the root first, I'm looking for the square root of 25, and then I want to take that square root of 25 and raise it to the third power. So if we think about this, what's the square root of 25? 5. So this becomes now 5 to the third power. And what is 5 times 5 times 5? 125. Let's take a look at another one. How about if I have here 81 to the 3/4 power? So what does that represent? Well, 81 to the 3/4 power means that I want to find the fourth root of 81 and then raise that to the third power. So what's the fourth root of 81? Well, 3 times 3 times 3 times 3 equals 81. So it's 3. And then I have 3 to the third power, and that equals 27. So that's how you work with rational exponents. The numerator of the rational exponent is your power, and the denominator is your root. So why do we use rational exponents? Because rational exponents can make it very easy to simplify radical expressions like these that we see here, which can be kind of confusing. But actually, once you rewrite them using rational exponents, they become easier to work with. So if I take a look at this first example here, I have here, I'm looking for the cubed root of 8y to the third power raised to the fourth power times the sixth root of 8y to the third power raised to the fourth power. So what I can do to make more sense of this, to simplify this, is I'm going to rewrite this but using rational exponents. So what that looks like is this. I'm going to say 8y to the third, and instead of writing it using the radical, I'm going to use this as a rational exponent. So remember, the top number is my power, so that's 4, and the bottom number is the root, so that's 3. So this becomes 8y to the third to the 4/3 power times, over here we're going to do the same thing. Again, 8y to the third raised to the 4/6 power. So a cool thing that you can do with fractions, with rational exponents, is you could apply all the fraction rules to them. So for example, I see that this second exponent here is 4/6, and I know that that can be simplified. So 4/6 can be simplified to 2/3. So I can actually rewrite this as 8y to the third to the 2/3 power. So now I need to go back on what I know about multiplying powers that have the same base. I know that when I multiply powers that have the same base, all I need to do is add the exponents together. So I see that my exponents are 4/3 plus 2/3. So I have to do that as 4/3 plus 2/3, and that equals 6/3. And just like you would do with regular fractions, is you would say, well, how can I simplify 6/3? Well, that equals 2. So now, this complex radical expression, we can now rewrite it very simply as 8y to the third to the second power. So now that I have 8y to the third to the second power, I could finish the job, I could finish evaluating by distributing this exponent of 2 inside this parentheses. So I have here, first I have, what is 8 to the second power? What is 8 times 8? Well, that equals 64. And then what is y to the third power raised to the second power? Remember, when you raise a power to a power, you multiply the exponent. So that becomes y to the sixth power. And this is my original expression, my original radical expression simplified. It is 64y to the sixth. All right, let's take a look at this next example here. I have here radical, and then inside I have a 2x to the second power, and then I have another radical 2y. So how can we make sense of this? Let's first take a look at this larger radical on top. There's no number in here, so that means this is a square root. So let's go ahead and rewrite that using a rational exponent. So I'm going to have my parentheses here, and inside I'm going to have my 2x squared and my radical 2y. And instead of putting that in a radical for square root, I'm going to use a rational exponent. So that is to the half power. All right. So now let's take care of this other radical here, this radical here on 2y, which again, you see there's no number here, so this is a square root also. So let's rewrite this. So now I have my parentheses, and all of this stays the same. And then now, instead of writing this 2y under a radical, I'm going to put 2y in parentheses. And again, the other way I can show square root is to write to the half power. Then I need to close this and still use this half power. Now this might look even more confusing, but when you start to work with it, then you realize this actually gets easier. So let's distribute this half power out here. When you raise a power to a power, you multiply. What's 2 times half? 1. So I basically have 2x to the first power, which is just 2x. Then same thing over here. What is 2y to the half power raised to the half power? Again, when you raise a power to a power, you multiply. So this becomes 2y to the 1/4 power, because half times half is 1/4. Now, I'm going to stop here because I don't really want to continue this, because 2, the fourth root of 2 is an irrational number. So we're trying to keep these radicals simple. So we don't want irrational numbers. So what I'm going to do is I'm going to just rewrite this expression going back into the radical form so that I can show this 2y to the 1/4 power. So I have my 2x, and then I have the fourth root of 2y. And so this is my radical expression in simplest form. All right, let's take a look at a third example here. All right, so we take a look at this one, and this one is 1/25x times x to the 9th power raised to the negative half power. So as we've discussed before, the best course of action here will be, let's get rid of this negative on the exponent. Remember that a negative exponent means reciprocal. So if I get the reciprocal of this expression, I can remove this negative off this exponent. So here we go. What's the reciprocal of 1/25x? It is 25x. And what's the reciprocal of x to the 9th power? It is 1 over x to the 9th power. And we're multiplying these. So now that I got the reciprocal, I can eliminate this negative off the rational exponent. So now this is just to the half power. And again, what are we going to do? We are going to distribute. So here we have, what is a 25 to the half power? Remember, that means the square root of 25. What's the square root of 25? 5. Then I distribute to this x, so this is 5x to the half power, okay, times, and so if I look here, right, I have 1 over x to the 9th power raised to the half power, so we have to multiply. 9 times half is 9 over 2. So this looks like this, x to the 9 over 2 power. Now when I multiply these together, I end up with 5x to the half power over x to the 9 over 2 power. So now what do I do with this? So we can remember that when you divide powers that have the same base, you subtract the exponents. So I have here 1/2 minus 9 over 2. 1/2 minus 9 over 2, and that equals negative 8 over 2, which equals negative 4. So when I simplify this expression, after I subtract my exponents, I have the answer, or the expression, 5x to the negative 4th power. And as we know about negative exponents, it means reciprocal. So if you have my variable with a negative exponent, the way I find the reciprocal is I just take this, and I know when I flip it, it's going to end up on the bottom of my fraction. So my final simplified expression is 5 over x to the 4th power. Because remember, after you make the move, after you move the exponent the variable that has a negative exponent, you remove the negative off the exponent. So this is my simplified expression. All right, 2 more examples right here. So let's take a look at this one. At first look, you're saying, what? Now I have a rational exponent that has a 1 over x. What am I supposed to do with that? Well, let's just take this one step at a time. Okay? So what should I do with this? Well, what do I know about raising a power to a power? I multiply, right? So let's just multiply this. What is 1 over x times x? Remember, this x is like a whole number, right? So that looks like this. It looks like x over 1 times 1 over x. Well, what does that equal? That equals x over x, correct? And we know that any fraction where the numerator and denominator are the same, that equals 1. So all of this has just become 2x to the 1st power, or just 2x. We'll just leave it like that. Now let's do this here, right? So now we're doing this exponent 2x raised to the 1 over x power. Again, treat them as fractions, right? How would we do this? We say, well, 2x over 1 times 1 over x equals 2x over x. So what's 2x divided by x? It's 2. So this becomes 2x to the 2nd power. Okay, so now what's next? Well, let's distribute this exponent here. What is 2 squared? 4. And x to the 1st power raised to the 2nd power is x to the 2nd power. So now I have 2x times 4x squared. And let's finish it off. Multiply the coefficients. What's 2 times 4? 8. And what is x times x squared? X to the 3rd. So my simplified expression is 8x to the 3rd. All right, last example. We have here x to the 10th power to the 1/5 power over radical, the square root of x to the 8th power. So first let's take this and rewrite this using only rational exponents. We can go ahead and take care of this here. What is 1/5 times 10? Well, it's 2. So now the top of this is x squared. Now the bottom here, let's go ahead and take this and write this as a rational exponent. Again, remember, power on the top, root on the bottom. So this makes this x to the 8 over 2 power. And again, what can we do with the fraction 8 over 2? We could simplify it, and it becomes what? It becomes a 4. So we can rewrite this as x to the 4th power. And now we say here, okay, what's x squared divided by x to the 4th? Whenever you divide powers that have the same base, you subtract the exponents. 2 minus 4 is negative 2. So I have x to the negative 2nd power. We cannot leave our negative exponent, so we need to finish this. We get the reciprocal of x to the 2nd power, which is, sorry about that, 1 over x squared. And that is our final answer. I hope this video helped you.